Well, hello guys and welcome back to Mr. G Physics. Here's Mr. G and we are going to be making another video for the grade 11s. However, grade 10s can get a benefit for this video. This is going to be a question on bonding, on atomic combination that some learners have been asking me to make, so let's dive into the video. But before we move on, don't forget to subscribe for the channel and like the video so you can get all the notification and videos I post on regular basis. Well, the question we're going to answer was question 2 done in November 2023 in the Gauteng province. Right? Now, this question says calcium carbonate is a diet supplement used when its intake of calcium throughout the diet is not enough. So if you have problems to take calcium, then you have to use this calcium carbonate. The body requires calcium to maintain healthy bones, muscles, nervous systems, and the heart. Calcium carbonate can also be used as an antacid to release heartburn. Calcium carbonate can be produced with the following reaction, and they give you a reaction to produce calcium carbonate. The question said draw the Lewis diagram for, and they give you two options there. But let's quickly have a look about Lewis dot diagram. I'm going to move down. I already copied the periodic table there, guys, and I'm going to write about Lewis dot diagram. Lewis dot diagram or diagram. So now in this diagram, what you are going to have is the symbol of the element. We use the symbol of the element and the valence electrons. The valence electrons are going to be represented with dots. Okay, so that is important to remember. Now, let's also remember what is going to be valence electrons. Now, what are the valence electrons, guys? The valence electrons are the number of electrons in the last energy level. So the number of electrons that you will have in the last energy level, that will represent the valence electron. Now, from the periodic table, for the number of elements we're supposed to study in or at school, there is the following that we can do. All elements in group 1 will have the valence, and this one is 4 valence. So all of this one will have 1 valence. All group 2 will have 2 valence. All group 13 will have 3 valence. Then it's 4, 5, 6, 7, and 8. That is the valence electron for the elements that are in those specific group. In the transition methods, we are not going to work with those in terms of valence. So we're going to work only with elements that belong to group 1, 2, 3, 4, 5, 6, 7, and 8. Saying that, now let's see. If we have to represent the Lewis dot diagram for hydrogen, all we have to do is, let's write here the example, is to have the symbol hydrogen with 1 valence. It's in group 1, the valence is 1, it means you draw 1 dot anywhere around that hydrogen. Now, if you have, for instance, let's say boron, now Br is the symbol for, B is the symbol for boron. Just B, I don't know where they are coming from. So the valence electron is 3, so you are going to represent 3 electrons. Now, let's imagine the boron is in a square. So we have 4 sizes. So we are going to always think of those 4 specific sizes there, like in a block. So the valence electrons are going to be represented in either one of the 4 sizes. All right, so for instance, it's 1, 2, and 3. That is the valence electron for boron. Obvious, the block must not be there. So if you remove the block, this is what you have left there for boron. Let's see, for example, nitrogen. So if you have nitrogen, the valence electron for nitrogen is right here, is in group 5, is 5. It means 5 electrons in the last energy level. So if you draw the valence electrons, remember, like if there is a square, there we go. So we have 1, 2, 3, and 4. You always place one valence in each of the 4 sizes of the square, and then you start repeating 1, 2, 3, and 4, and the 5 is there. So in this case, you can see that nitrogen have 3 unpaired electrons and 1 lone pair. This one, guys, is called a lone pair. Lone pair of electrons. This is called lone pair of electrons. So this is an example of how to represent simple atoms, just an atom. Now, when there are combinations, like in the case, we have 3 different types of bonding. Mainly, we have 2 different types of bonding in which we do the Lewis dot diagram. Those are the covalent, and that is the ionic. And I don't want to go to a whole lesson of this one. So bonding, you did 3. That is covalent. You did ionic, and you did the metallic. Both of this one here, they need the Lewis. But they are different. Covalent is different from ionic, okay? So now, just for you to remember, covalent is when the electrons are going to be shared between the atoms. So these electrons are going to be shared. Share electrons. All right, and then the ionic is going to be a transfer. It means electrons are going to move from one atom to another. That is what happened into the ionic bonding. Let me have a cup of coffee, sip of coffee. Okay, so this one is a little bit of a lot of information, right? First, Lewis dot diagram is a symbol with the valence electrons represented with dots. We have different type of bonding, covalent and ionic, both of them, we must be able to draw the Lewis dot diagram. Now, you need to have in mind what happened when it's covalent, what happened when it's ionic. In a covalent bonding, there are going to be a share of electron. In the ionic bonding, there's going to be a transfer of electrons. So when you have done already the Lewis dot diagram for each atom, you can see that the ones that are unpaired, for example, and let me just use another color here. In this nitrogen, I have 3 unpaired electrons. Those are the ones that can either be shared or it can either be transferred. Some of them are going to transfer, some of them are going to only share. But that is the one. So you can see that hydrogen have 1. That electron of hydrogen, valence electron, can be either share or transfer. It depends. Now boron have 3. All of them are unpaired. It means boron can share or can transfer or can take different number of electrons. So that is with boron, okay? So now with the question, moving back to the question, we have to do the Lewis dot diagram for carbon dioxide and for calcium ion. So let's do here the question. We didn't answer the question yet. We're just going a little bit around the explanation. So calcium carbon dioxide, sorry, this one is question 2.2.1, I think. 2.1.1. 2.1.1. 2.1.1. I want to work organized. 2.1.1. We have carbon dioxide, CO2. Now, to do this one, let's identify. This one is covalent. How do I know it's covalent bonding, guys? Because it's the combination of metal, the combination of two non-metal. It's a non-metal plus a non-metal. There is a covalent bonding. It means they are going to share. So we're going to do, first of all, the Lewis dot diagram for each of the different atoms we have there. So we have one carbon and we have two oxygen. So carbon, if you remember and you move back to the periodic table, carbon is in group 4. It has 4 valence electrons, guys. It is 1, 2, 3, and 4. That is the Lewis dot diagram for carbon. For oxygen now, we have 2 oxygen. Let me just draw one oxygen here and the other oxygen here. Each oxygen will have a total of 6 valence electrons. If you move here, oxygen has 6. It's a group 6 of 16. So if you represent now the valence electron will have 1, 2, 3, and 4. Remember to do it in that way. 5 and 6. The other oxygen, same story. 1, 2, 3, and 4. 5 and 6. That is 4 oxygen. Remember of the imaginary 4 size square there. So now what we see here, if you remember what I explained just now, we have that carbon have 4 bonds. Those 4 bonds can be shared. What am I speaking about share? Because we identified that it's a covalent bonding. So in this case, everything is going to be shared. Carbon have 4 electrons and it can be all shared. Oxygen have 6, but only 2 unpaired. You can see that oxygen can share those or can give away, but in this case, it's going to share those 2 electrons only. So how can we fix this one and make the bonding for carbon dioxide? Well, what is going to happen here? The carbon will have 2 electrons that are going to move together. So these 2 electrons, for example, let me see if I can write here. These 2 valence electrons will be moved so it can share these 2 of oxygen. So each of them are going to share those. And the other one, and I'm going to now maybe change the color, the other one of carbon, these carbons, valence electron will share with the other 2 of the other oxygen. In other words, to do this one, we need to have carbon in the center. The 2 electrons of carbon are going to move here and the other 2 will move there. That is what happened to carbon. Here is going to share with the oxygen. Let me just go back and use the color. Here is going to be the ones of oxygen, and I'm speaking about the unpaired electrons, and then here is going to be the rest of the lone pair. Guys, you cannot take the lone pair away. Now for the other one, it's going to happen the same. It's going to share the 2 electrons for the other oxygen. Oxygen is there, and then the rest of the lone pair must be also drawn there. This one is the covalent bonding of the Lewis dot diagram for carbon dioxide. The bonding are this one here. This is one bond, this is another bond. This is one bond, this is another bond. Alternatively, you know how to do it, then you can say carbon dioxide, double bond with oxygen, the lone pair must be there, then double bond with another oxygen, and the lone pairs must be there. This one is the Lewis dot diagram for carbon dioxide. However, you can represent it like this, and believe me, you will get full mark because it's completely or entirely correct. The next one is for calcium ion. Now, calcium, we have to represent the Lewis dot diagram for calcium, Ca2+. Now, how calcium became Ca2+? If we go here, calcium is in group 2, will have a valence electron of 2. So from here, you will have that calcium is Ca with 2 dots, 1 and 2 dots. Let's draw the dots in the other side. Calcium gave away those 2 electrons in order to become calcium 2+. So calcium become Ca 2 plus because it gave away those 2 electrons. But if you give 2 electrons away, it means that you become more positive. This one is neutral. It doesn't have charge. When you gave 2 electrons away, this one will come positive 2. So how do we represent the Lewis dot diagram for that calcium 2 plus? Quite simple, guys. It's just Ca 2 plus, but the 2 plus is coming out of a bracket, Ca, that loses the 2 electrons, become positive 2 or 2 plus. This is the Lewis dot diagram for the ion. That is the Lewis dot diagram for the ion. I hope it's clear in terms of covalent bonding. This one is not a bonding, it's a formation of a ion. So let's go to the next question. So far, so good. We move a little bit further up. Question 2.2. Define covalent bonding. And guys, we already spoke about that one. Okay? It's a bond. I'm just going to write it. But we already spoke and explained about that one. It's a bond where electrons are shared between atoms. All right, the result is going to be a molecule. So since the moment you hear the word molecule, it means the bonding that form those different atoms is a covalent bonding. Identify the metal in the above reaction. Now, if we go into reaction, this one is just memory. You need to remember from the periodic table which ones are metals and which ones are not metals. So from this periodic table here, remember starting from a bottom, which is a semi-metal. Let me just get maybe another color. Let's do it with the blue. If you come here, this zigzag line divide from metals on the left hand side. These are metals. All those are metals. I don't know what happened there. And these ones are non-metals on the right hand side. Non-metals. All right, so that one is known by you. It's just a memory, guys. Calcium is right here. It's element number 20. It is a metal. It is a metal, so it's not much to speak. It's really a free-for-all mark, this one. Identify the metals. That one is Ca. That is the metal. Explain a metallic bonding. Now, metallic bonding is not much to do. It's really easy. But what happened? Metals generally have a lot of electrons, and those electrons, the attraction between the nucleus and the electron is not as strong because they go to a next energy level all the time. So the attraction is not that strong, and the electrons that are in the last energy level, those electrons, they can get delocalized, they can get confused, for instance. And one electron of one atom can get mixed with the electron of the other atom, and that is how the metallic bonding is formed. If we write it here, I do have it at the front, is the bond between, so let's write it down here, bond between positive ions and the localized valence electron. Delocalized means that those electrons that are very far from the nucleus get lost. They get lost where they are, and they can be confused with the other one. They are attracted by the next atom or ion. Which of the two reactants in the reaction would most likely be a gas at room temperature? Guys, another free mark. Carbon dioxide, you know, is a gas. A solid at room temperature. Now, say, how do you remember which one is a solid. This is a solid. This is a formation of calcium oxide. The reaction between calcium and oxygen, the product is always an oxide, which are all solid. All oxides are solid. All right? So in this case is CO2, and this one is CaO, calcium oxide. All the oxides are solid, guys. Define electronegativity of an atom or molecule to attract the bonding pair. So the stronger the electronegativity, the stronger they are going to pull the bonding pair. For example, what is going to happen if I pull, let's say my pen here is the bonding. So if this is one molecule, this is another molecule, or one atom, another atom, whoever is stronger is going to pull towards that side, that bond, and then there is more electrons next to that one that is pulling stronger. There is more electrons there. So this side of the charge becomes slightly more negative than the other. So whatever side is pulling stronger, it means on that side it's going to be more electrons around the atom. That's why it's coming slightly more negative than the other one. The question say, use electronegativity to determine the type of bonds that will form in calcium oxide. So all you have to do is to calculate the difference in electronegativity for calcium and oxygen, and then be able to identify this table I'm going to post so you can see how to do it. So now here's calcium, which is 1. Let me see, I cannot see properly. It's 1, and then oxygen is 3,5. So it's 3,5 minus 1. The difference in electronegativity is 3,5 for oxygen and 1. So difference in electronegativity here is 3,5 minus 1. This is equal to 2,5. I'm going to show you the table right here, but you need to remember that that one will be ionic bonding. You just have to show the difference in electronegativity. You have to show because that is what to do. Will CO2 be polar or non-polar molecule? It is a non-polar molecule. It's quite simple, guys. It's a non-polar molecule. That is a non-polar molecule. Carbon dioxide is non-polar. We have, remember, it's carbon, O. This is carbon dioxide. This is the Lewis dot diagram, but it will help us. It's a linear molecule. Oxygen have a greater electronegativity than carbon, so it will pull that double bond stronger towards itself. It means that oxygen, for instance, for say, will be slightly more negative than carbon, and that will happen on both sides. That is why that oxygen of this molecule is a non-polar molecule. It doesn't have two poles. Question 2.3, explain the answer by using the calculation and referring to the shape of the molecule. What is the shape of this molecule? This is a linear shape. All right, so when you calculate the difference in electronegativity, even though you get a polar bond, the shape is asymmetrical. You know, to explain this one is a little bit complicated, because what to say? You get the polar bond, but then the molecule is non-polar. Okay, so they say calculate the. They want you to calculate the difference in electronegativity. So let's do it real fast. Change in electronegativity is equal to the electronegativity of oxygen is 3,5 and for carbon is 2,5. So it's 3,5 minus 2,5. This one is going to be equal to 1. And that type of bond is a polar. Now, the fact that a molecule have a polar bond, it doesn't make the molecule a polar molecule. This is a symmetrical molecule. I just explained to you here with the shape, all right? So why is the molecule a non-polar molecule? It doesn't have two poles, guys. It's asymmetrical, even though the bond is a polar bond. Guys, this is the question of the answer of this question. I hope it helped. If it helps, sum up, subscribe to the channel. Thank you for the support. I'll see you next time. Mr. G here.